Thank you everyone for being here and welcome to Kevin Elmy, and to the session, including cover crops in your rotation, a whole system approach. This is part of our virtual learning series from the New Brunswick Soil and Crop Improvement Association and Canadian Organic Growers. And support for this activity has been provided by the On Farm Climate Action Fund. And we'll share some information in the chat about how to access support through the OFCAF, as we all know it mostly, fund during this presentation. I'm going to go straight to you, Kevin, hand it straight to you. It's what I do, and let you give your own small intro and get right into it. Yeah, and we'll jump in. And this event is being recorded for future options. We had lots of RSVPs, but I'm not sure if everyone was able to make it. So make sure that'll get shared. And yeah, straight to you, Kevin.
All right. Well, apologize for the delay. That's the joys of working remotely. Had some technical issues, but I think we got them all sorted now. So as long as I don't run out of data, so we'll be doing good. So yeah, we'll dive right into it. So my background is I have my degree from the University of Saskatchewan in agronomy, specializing in soil science or crop science and minor in soil science. Started my postgrad diploma in soil chemistry. From there, worked around Western Canada, bought a farm and moved back to Eastern Saskatchewan in 1999. And that's when I realized I didn't buy soil, I bought dirt. And so I realized that I had to change the conditions of our soil. So started using a lot more biennial crops, so winter wheat, then switched to winter triticale, started playing around with soybeans, corn grazing, short-term forages in rotation. And from there, just got introduced to cover cropping in the mid 2000s, and from there, it became a very uh, solid staple of my management system. So, and from there, started Cover Crops Canada, I think about 2009, and started setting up retailers across Western Canada. Since then, sold the farm in 2022 and went full-time coaching for the regenerative. I've been talking about soil health in Western Canada since about 2010, and since then have been invited into the United States to do coaching and helping producers. In this last June was over in Ukraine for 3 weeks. Spent a year in so 2023, spent that in Australia, and right now just finishing up a 75 day tour through Western Australia. And now I'm in Eastern Australia. Just finished up our last workshop here, so going to be heading home. So there's the quick history of me. So in the meantime, now what we'll do is dive into the presentation. So including cover crops in your rotations, a whole systems approach. This is that whole thing of if, anybody that has been playing around with cover cropping or regenerative agriculture principles, and as soon as they start saying, well, it really didn't work, it's basically they didn't have they failed some part of the foundation. So as we go through this, if we have everything rolling and have the patience, because we've spent the last potentially 100 years managing the soils to degrade them, to fix them and bring them back to function, isn't it takes more than just the one season potentially. But basically after about 30 to 60 days, normally you can start seeing signs that your soils are recovering. So the basic definition that I use for cover cropping is to grow plants to protect and improve the soil. I don't like some of the definitions that are out there, because they're trying to encompass all the aspects of cover cropping. But then when people look at it, they say, well, I can't cover crop because I don't want to do this. I can't do this. The whole thing, and once again, when we look back, cover cropping is not a new idea. It's been used for literally centuries. And basically, all they do is they want to grow these plants to protect and improve the soil. And even if we are talking about just weed growth, as long as we're not creating more of a issue down the road, weeds are actually uh, trying to improve our soils. And it's really that's one of the mind twists that we have to maybe get our heads around. But if we are
Kevin,
looking at,
I'm sorry to interrupt, but you're
yeah,
still on your title page of this presentation, and
oh, pause. Oh, geez.
I have
Okay.
a feeling you don't want to be there.
Yeah, exactly. Thank you. So
Um,
paused. I don't know why it does this sometimes. Screen is sharing. Continue to share. It's paused. How do, oh,
I do also have a PDF version if we need to switch, and I can share. We can go from there. Let's see what happens though.
okay, so this, it's sharing. Stop share, and then we'll go back into it. So it's sharing. It's paused. Love technology. Love technology. Love technology. This is the first time this has ever happened. Sharing. I'm gonna try stop sharing. Screen sharing. Okay.
Okay,
There we go.
thank you.
Okay, continue to share. Awesome. Thank you. Thank you for because it saves a half an hour of just looking at the covers, my cover slide.
Of
So,
course, thanks.
this definition of cover cropping, growing and protecting, growing plants that protect and improve the soil, it needs to be goal oriented. So if we allow nature to provide our cover cropping, what's going to happen is nature's going to give us the plants that she feels that we need to do or she needs to improve the soil. What we want and what nature wants may be slightly different. So what we need, so if we want these weeds to grow and we're content with that, then absolutely, nature will give us the best species to do what she wants to do. If we want certain ends, we need to be picking species that have the same ecological function as these weeds. And we'll get a little deeper into that later. And when we're doing this cover cropping, we need to be guided by our soil health principles. And whatever the soil health principles, number one, keep a plant in the vegetative stage for as many days possible through the whole year. Number two, increase functional plant group diversity. We want to reduce the amount of tillage we do. We want to reduce our reliance on synthetic inputs, and we want to properly incorporate livestock when possible. So goal setting, basically what we're looking at is if we can stay away from that Y word, yield, and actually address issues with our production system, which will then affect our Y word yield. Dr. Chris Nichols says this is the first word we need to get rid of in agriculture, get rid of the word yield, and of course it's universal. We've been using it for so long. It gives us an idea of productivity. But what we need to do is look at what's limiting our production. And from that, we need to identify, is that a symptom of a problem or is it the actual cause of the problem? That is one of the keys that we look at. We need to understand the limitations of our system. So we need to look at what kind of equipment, what kind of time, moisture, crop rotation, our environmental inventory, things like that, so that we can go ahead and pick the right species to make things work. If we have tried growing species that aren't adapted to our system. Even though, we, in theory, we could grow them, but our system isn't ready for it, then it won't work. And then we have to go through and look at what all of our options are. And so this way we can create a management system instead of trying to piecemeal it together. So a cause versus symptom. By definition, if we go through and we look what a symptom is, an expression of a disorder. The cause is something that makes something else happen. And this is when we go through this, it's a little bit of a fine detail, but when we start doing the planning, when we start looking at fixing the system, it's really important because if we just treat a symptom, that symptom will reoccur if we haven't addressed the cause of the symptom. So, sounds a little philosophical, but in the big picture, it's really important when we start looking at actually finding a solution that will persist. So, talked about a little bit the weeds. Why do weeds grow? It's because they like driving us crazy and makes us spend money on controlling these weeds, whether organic or conventional. And when we start looking at the system, like so for wild oats, for redwood pigweed, lamb's quarters, dandelions, if we go through all of that list, we've been fighting them for, you know, hundreds of years, and we're not winning, even though we have all this technology, we have all these strategies. But why? These weeds are actually trying to fix our soils. So when we go through and being able to read these weeds, and one of the books that I highly recommend is When Weeds Talk by J.L. McCammon. It's a great book to understand the conditions, why some of these weeds grow. These weeds are actually trying to fix their soil. They are a symptom of what's not right in our soil. And so whether it's excess soil nitrates, it's salinity, anaerobic conditions, low micronutrients, these plants are adapted to grow in these conditions when the cash crops, the perennial plants that we're growing, are struggling. The conditions are not right for those, but they are right for these weeds. So if it is excess soil nitrates, certain weeds want to grow. And this is where our whole soil testing system needs to be addressed, because when we're just testing for nitrates and basing our nitrogen applications on nitrates, it's great for growing weeds. It's great for producing insects, and it's in issue insects, and it's great for producing diseases. When we start getting away from this excess nitrates in our system, a lot of our problems disappear and our bricks start increasing. So these are the things that we need to understand when these plants are growing. What are they telling us? So I'm going to go through some examples right away. So if we go out and we kill weeds without changing our management, those weeds will continue to come back year after year, and it may be the climatic patterns change, and then those weeds will disappear for a couple of years, but in the future, bang, they start coming back again. And it's because we're managing for these weeds. We need to understand what ecological advantage each weed has, and especially the ones that really bother us. How are we managing that are triggering those weeds to keep wanting to come back? Once we understand what triggers them, now by changing our management, we can take that advantage from that weed, take it away from them, and replace it with another plant that has similar ecological function. And when we start doing that, now we start repairing the soil we're heading in the direction that we want. And when that happens, we get a lot happier. Usually economics get better, production improves, all these other good things in the system. So if we look at some common weeds, I did a quick Google search of common weeds in New Brunswick. So this way I tried keeping things relevant for you. There are some of them that I wasn't sure, and because I'm on the road, I didn't have enough time to do a lot of research on them. But lamb's quarters, it's one of them I have pictures of, and it occurs around the world. We were in a soil pit 2 days ago here in New South Wales in Australia, and there was lamb's quarters growing. So it's once again, it isn't just a local thing. It occurs around the world, very common. And what is it? What does it tell us? So lamb's quarters is a soil nitrate accumulator. So when we have excessive amounts of soil nitrate, these plants are triggered to grow. Its function is to tie up those nitrates, convert it over to amino acids and proteins, re-release it as a root exudate into the soil. This way, it's going to be feeding our plants that we want to grow, our higher successional plants, and we're not going to lose this nitrogen from the system. When we have black fallow, or we take out these weeds that are doing this function, that gives a window in our system that we're going to start losing nitrogen potentially. So yes, that plant's going to be tying it up. They're non-mycorrhizal, so this way they're not going to release it until they die and they rot down. But these are the things that we're going to be, we don't like that idea. What else can we do? So the way we can address this is using a biennial grass to use some annual clovers, some other mycorrhizal plants that will stay in that vegetative stage. And that's one of the reasons why that step number one is so important in the soil health principles, having that green plant. When a plant is in the vegetative stage, it's going to be photosynthesizing, it's going to be releasing root exudates, it's going to be soaking up soil nitrate because soil nitrate is passively taken up by the plant. It is a toxin to the system, to the microbes. If you have high nitrates in your plants and the animals eat it, it's too high nitrate, your animals can get sick or die. When we have high nitrates, we will never have high bricks in our plants. And the high bricks is our measure of photosynthetic activity and when we start looking at that, and the reason why it always stays low is when that plant soaks up that one molecule of nitrate, it takes four molecules of water to break down that molecule of nitrate to convert it over to start the process and to convert it over to amino acids and proteins. When we have that all that water coming into the plant, even though the plant is photosynthesizing, it dilutes the sugars in that plant. So we may see growth, we may see green, but we'll also see really low Brix levels in that plant. When we have low Brix levels, that's an invitation to disease and insects. So it's a really interesting way of looking at this management system. When we have that biennial grass, it'll only grow so high in that first year before it vernalizes. And when it's been soaking up this nitrate, converts it over to amino acids, proteins, that plant then says, why do I have so much amino acids, proteins in my system? Starts releasing it as a root exudate. When we have mycorrhizae fungi, it will move that nitrogen amino acids either into the microbes or shuffle it over to our cash crop that we're going to be feeding. So yes, there's going to be an initial tie-up, but it's going to be initial tie-up either through weeds or these biennial plants, and then through mycorrhizae, get them into our cash crop. So that's one of the reasons why I want that biennial grass in it. The other thing we need to do is if we're either conventional or we're organic using manures or green manures, we really have to manage our nitrogen applications. And so this is whether we're, spreading manure, adding synthetic fertilizer, or we're going out with green manure. So we have to have a green manure that will have both a grass, a legume, and a broadleaf, ideally. And then after we have that plow down, either incorporated or rotted down, we should have a plant growing to recapture any nutrients that as that material starts rotting down, gets recaptured. Dandelion. It's another interesting plant that you go around the world and there it is. And what is it doing? It's telling us once again the same story. It doesn't matter where we are in the world. So it's an indication that we have some anaerobic soil. So this is, what we refer to as compaction. And one of the things through, my training through university is, looking at a soil test, we may have 9,000 pounds of calcium in our system, but it's just ends up not being available. And this is what I talk about a low calcium flux. So if we look at our base saturations, numbers on a soil test, and we'll see a reading of 65% calcium, which is pretty close to ideal. When we start looking at it and we understand the shape of clay in our soil, so it is like a piece of paper. And when they do a base saturation, they're basically estimating that if there's 100 spots on that piece of paper, we're going to be having 65 of those as calcium. When we don't have the nice separation between those clay particles, and we have basically a book that we have it closed, how does a plant get that calcium from the face of those pages? It can't. It can get from the outside edges. If we have the mycorrhizae in between those sheets of paper, now we can be pulling calcium out of it. So if we don't have the mycorrhizae, we don't have the really fine soil organic matter, and we have that compaction, we don't have that extra release of calcium into the system. When it doesn't, now the dandelion throws the taproot down, gets some aeration in it, brings up and accumulates calcium and phosphate, and basically gets the calcium flowing from deep in the soil profile, bringing it up. When the leaves die and when the roots die, it releases that calcium to help loosen up that soil. So when we have this compaction issue, it does show that we have a low calcium flux. So we need to get more taproots into our system as either cover crop or cropping rotation. We have to stop over applying nitrogen, because when we add too much nitrogen to the system, what happens, we have to maintain our carbon nitrogen ratio in the soil. And when we add nitrogen to the system, the microbes need to eat carbon. If we don't have the root exudate, what's going to happen is the soil organic, or the soil organic matter is going to be now the target for the soil microbes to get their carbon. So as they eat the soil organic matter, we're getting less and less of that carbon between our clay particles. Then we cause our compaction. And that's whether it's synthetic, whether it's organic. It's like organic from the standpoint of nitrogen fixed by plants, or adding manures or anything like that. So we have to watch that nitrogen application. So ideally we should be doing split applications of our nitrogen, or we're doing too much tillage, which once again really damages our fungi, ruins our structure, and causes that compaction. So basically, to increase that calcium availability, just do the opposite. So to increase our calcium flux, so can we go out and there's a really good Facebook feed about, especially being on the East Coast, any of the shellfish, especially oysters. If you take oyster shells, clean them up really good, so there's not a lot of contamination of microbes, and you soak them in vinegar, it's a really powerful calcium source. So you dilute it to 100 or 1,000 to 1, and it's very bioavailable, and a great way to get that calcium in there. We could be adding hydrolyzed fish. We could be adding a few other products that have really high calcium properties. We'll get more taproots in rotation, manage that nitrogen application, and reduce our tillage. And then they magically disappear. So some of the cover crop options that we have, and once again, just to put labels on things so we have an idea of what we're talking about, we can have a pre-seed cover crop. So this is going to be seeded prior to seeding our main crop and then terminated before our cash crop. We can do intercropping, so we're growing two cash crops together or more, and then either selling it or feeding it as a mix or separating them. We have relay cover crops, so we're going to grow their cash crop. We're going to add a cover crop to it, which will stay underneath the cash crop and then continue growing after we finish harvesting. We have a post-harvest cover crop, so we can see it after we finished harvest, or we can have a full season cover crop. And the whole thing of when we start looking at these different options, what we want to do is when we look at this functional plant group scenario, is I like 5 because I have 5 fingers. I can remember that if I'm missing one, which one am I missing? So hopefully I don't lose any fingers. So the functional plant groups I go with are grasses, legumes, brassicas, broadleaf, and forbs. When I first started out, I was talking about grasses, legumes, and broadleaf, and I didn't even think of it, it didn't occur to me. But the American Indians, that's exactly what they're growing when they're growing their maize, beans, and melons. So, it once again not new information. All we're doing is maybe break it down a little different, so we have a little more flexibility. So, because of the broadleaf, they're so broad, I wanted to break it into a little more functional plant groups. So the brassicas and non-brassicas and forbs. Once we start doing that, we start looking at warm and cool season species of each, annuals and biennials and perennials of each of the warm and cool seasons. So this is where we can get all of this plant diversity. Do we need all of them? No, but when someone says that they have a cover crop and they have lots of diversity because they have oats and barley, wheat, triticale, and peas, in reality, that's only a cool season annual grass and a cool season annual legume. So how do we get more? So when we start looking at this, when we start designing these blends, we need to know the ecological function of each and one of these species. We have to determine which one of the species plays nice with each other, and if we have too much antagonism. So when we look at the brassicas, I keep brassicas away from any any time that we need nutrient availability to our cash crop. Keep your brassicas away because they are nutrient scavengers. They're going to take the nutrients, tie them up, and hold them for the full season, unless you can terminate them in crop. So at the end of the season is when I use most of the brassicas, just because our crop growth is slowed down unless we're growing biennial crops, and we want to tie up those nutrients so we're not losing them over our winter period. When we have these mycorrhizal plants, most of them are very friendly to put into these mixes, but now we have to, balance our cool season with our warm seasons. So if you put the warm seasons in too early when it's too cold, they're not going to do well. And once, which then leads to the next one, we have to watch that plant density. So if we have um, if we're going to be adding diversity. The quick rule of thumb is the plant density at when we're done with the cover cropping and the cash crop, we want to be about 120% of the monocrop seed density. So if we are seeding oats and we're seeding it at 30 seeds per square foot or 300 per square meter, what we want to do is reduce that seeding rate by about 10 to 20%. So take out 30 to 60 seeds per square meter and replace those with our cover crop. So we're going to be able to put 30 to 60 seeds per square meter of a cover crop, and we still have room to put another 20%. So we could put another 60 seeds in there to get, about 90 to 120 seeds of a cover crop under our cash crop. And given what species we choose, we'll be able to really boost the biodynamics of our system. So what species do we want to use is going to be determined by what our goals are. That's the reason why we really need to have that first step of what do we want to do. And with the uh, the turmoil in the world at the present time, nitrogen is a very key topic right now. And all along, so on our farm, when we got into the cover cropping and getting our rotation um, prioritized by low input crops, the last 15 years of farming, I did not buy a single pound of nitrogen for our whole farm. And people would come out and say, well, okay, if you didn't buy nitrogen, what kind of crops were you growing? And so our winter triticale and our spring triticale, it was nose high on me, and I'm 5'11". So there's some good growth there. Our soybeans, once again, you have to remember I was in eastern Saskatchewan. Our soybeans were averaging about 35 bushels an acre. We were growing corn for grazing. Didn't fertilize that either. And we were uh, getting about 15, 16 wet tons per acre with that, with no fertilizer. So and then our hay crops, da 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 da. So productivity wasn't an issue because right now we're breathing about 70 between 76 and 78% nitrogen. So we have lots of nitrogen in the air. We just have to get it from the air back into the soil. So when we're designing these blends, we want to go through when we're picking these species, we need to know the seeds per pound that each one of these species has. We need to know that monocrop seeding rate. So this way we know what a pure stand would look like. We need to know the days to flower. So this is how quickly is it going to go to seed? Is it going to be compatible with the crops that we're growing? We need to know the overwintering potential of these because do we want them overwinter or do we want to terminate by frost? We need to know the plant height. We need to know when is that period of fast growth of that plant, or is it a biennial and it just kind of pops up out of the ground and does its thing under the shade of the cash crop. So once again, this nitrogen thing, how much are we breathing? 78%, 76, 78%, depending once again on concentrations, all the other good stuff. And these legumes are, that was the cornerstone of my management system. It wasn't going in necessarily and having pure stands of legumes. That is in a lot of cases counterintuitive to what we want to do. Now we have all that nitrogen in the soil. In order to get a lot of these nodules and get proper nitrogen fixation, the breaking of those dinitrogen bonds takes a lot of energy, so we need a lot of phosphate in our legumes. And if we just allow the plant to fend for itself, and hopefully we have enough mycorrhizae, it'll work. But when we start doing these mixed stands, our nitrogen fixation by our legumes must take off. Once again, there's no science with it, or there's science behind it, but there's the research hasn't caught up with what the farmers are doing. So when we start working with these mixed stands, and we have mycorrhizae, so that's the importance of making sure we don't have any seed placed fungicides. And then the people get excited because, oh, we're going to have all these root diseases. Once again, we have the root diseases because we don't have the biology alive. If we do some compost extracts and do some biological seed dressings, and we get some trichoderma, we get some of these other natural antibiotic microbes in our system, the diseases are a non-issue. So, so when we have these mixed stands, we have the nitrogen fixers, we have the phosphate accumulators, which are basically grasses plus some of the things like chicory and the plantain. And what happens is we get a way more efficient system of fixing nitrogen and sharing nitrogen in the system. So back when I was growing some sweet corn, I would go out and I would seed a pure stand of, well, basically a pure stand of some annual clover, so subterranean clover, Persian clover, crimson clover, along with some Phacelia, and usually just a pinch of Italian ryegrass. And I would let that get, you know, 5 to 10 centimeters high, and then I would seed the corn into it. And the people, when they would buy the corn, they said they've never tasted corn like that in their lives. The mycorrhizae was firing. We had the clovers fixing nitrogen. We had the Phacelia pumping out root exudates. We had the corn and the Italian ryegrass um, building soil structure, and so the system was working beautifully. And once again, when we would look at our corn, the any other crop was frozen and done in the fall. Yet because we had high bricks, our corn crop with all of that biology kept on chugging. So it once again just another benefit of having that strong bricks plant in the system. So the two keys, make sure there's no fungicide on that seed and make sure there's no excess free soil nutrients in our soil. So anytime that we have excess soil nutrients in the soil, the plant will use that excess soil nutrients first. It doesn't need the mycorrhizae. The mycorrhizae is a bit of a burden on these plants. because in order to get these nutrients, that plant has to feed this mycorrhizae carbon, whether it's sugar, oil, protein, oils, all the other good stuff. So that we really need to really tie things up, and that's the reason why those fall cover crops are so important. We don't want to have this loose nutrients in the soil. To give another little example of this, had one of our customers. They were growing peas. They harvested peas off early, and they wanted to do a trial on these radishes. They grabbed the radish seed. They went home, seeded them. They had some pretty good growth in the fall, and right before freeze up, they went out and soil sampled. They sent soil sample away. They were going to grow oats the next year, and the soil test came back. They needed just piles of everything. In the spring, when the radishes rotted, he went out to the same spot. He GPS benchmarked them. And so he grabbed soil sample, sent it away. And after the radishes rotted, the soil test came back saying that he needed nothing. There was enough nutrition to grow that oat crop without adding any nutrients. And it just basically shows that radish soaked everything up, held it in place. We didn't lose it over the winter or in the spring with the runoff, and now get those plants growing and get it going. So so that whole system is so important. And so when we do stuff like this, we have that legume growing in with our cash crops. It's helping our system. It's not a competition. Yes, it'll tie up a little bit of water, but the whole thing is we want to manage that plant density. The other thing is growth rates. So if you have a slow establishing cash crop, you may have to wait, delay, and add the clovers after your cash crop is established. Things like corn. So we can go in and we can do some, once again, legumes and grasses are designed to grow together. So as long as we're not dealing with a biennial legume, we can seed the corn into an annual. They're relatively slow establishing. We have to watch if we're conventional, if we're going in with some herbicides, we're using herbicides that are going to be compatible with it. Otherwise, we're going to do our and even conventional, if we do our weed removal and then add these clovers after, it still can work really well, assuming we have moisture. Once again, paying attention to what weeds you have. If you have nitrate-loving weeds, is it going to be worthwhile or beneficial adding those legumes? Because if it will be beneficial later, but initially you have excess nitrogen in your system. Your calcium, where the calcium is located, is in your cell walls. It helps to give that nice brick type of structure. When we don't have that calcium, good calcium in the cell walls, then we don't have the bricks making a solid wall. This opens up the plant for disease. And this is, if we have these calcium in these cell walls, then the more cell walls we have in the soil, the more calcium we're bringing up. And this is where these tubers like the beets work really well. So beets, potatoes, radish, turnips, all those tubers, when they're in the soil rotting, they release just piles of calcium. And the reason why I like using plant material as a calcium source is when we put in gypsum and lime, if you look up the Mulder cycle, calcium is a bit of a party animal, so is phosphate. And so calcium's a +2, phosphate's a -4, so they bond. And so if you have a cow that dies and you dig it up after 10 years, what do you find? You find teeth and you find bones, calcium phosphate. So very, very stable in the soil. So this is where I would rather have this plant material getting rotted down, releasing it into the soil to make that work. The other thing we can do is use these deep-rooted mycorrhizal plants. So, the alfalfa will bring up a fair amount of calcium if we're returning that alfalfa production back to the soil. Or chicory. I know chicory can become a bit of a weed in areas, but what it does to the soil is absolutely amazing. It's a calcium and phosphate accumulator, strong taproot. The biggest thing for management is making sure that we don't let it get past flowering. And it may persist for a few years, but on our farm, we would see it at year 1, it would be a rosette, year 2, a big blue flower, year 3, I didn't have to kill it because it wasn't there. We had a good calcium cycle in the system. We had uh, rising phosphate availability in the soil, so it wasn't a problem. It did not hang around more than 2 years. So when it hangs around more, that means your calcium phosphate cycles haven't been fixed yet. And so just manage that flowering, and you'll have a powerful way of improving your soil. So when we look at cereals, one of the things we can do is intercropping. So we're going to be mixing a cereal crop with ideally a legume crop. We can use some broadleaf. My grandfather was a member of the Saskatchewan Field Husbandry Association back in the 1930s. So I did some research on that, and one of the last trials that they were working on was the best rate to mix oats and flax together. The reason why that's a really good mix is they're very both of them are low nutrient users relatively, um, and they're highly mycorrhizal, so that they're able to share nutrients and water together. Some of the other options are oats and peas. Fair amount of that is being used in Western Canada. The thing with that is, anytime you're doing these mixes, you always have to talk to your buyer to say, okay, if I have a little bit of pea chips in my oats, is that okay? Or if I have some oats in my peas, barley and lupin will be another really good mix, along with some other mixes. So in the mix that you see in the picture, this is oats with Italian ryegrass and subterranean clover and Persian clover. So there's two clovers in there. There's some Italian ryegrass and the oats. They harvested the first strip as silage, and the rest of the field they're going to harvest for grain. And underneath, the competition wise, when people say, oh, the competition, this is more for a relay cover crop. Um, Basically, there was an organic producer in Spalding, Saskatchewan. I told him about this mix, and he said, okay, he'll skip the clovers right now. He'll just put a pound of Italian ryegrass in with his oats, and then right beside it, a field of oats without the Italian ryegrass. It was a dry year, it was about 60% of the moisture of normal. And what he found was where the oats without the Italian ryegrass yielded about 3 bushels more, but where the oats with the Italian ryegrass underneath it had 80% less weeds. And so the question was, how much of that 3 bushel yield gain was weeds? So it even under dry conditions, it will provide some service. So another option for the relay cover crop is putting in wheat and subterranean clover. Once again, subterranean clover grows nice and low. Persian clover will grow quite a bit taller, but once again, depending on your management, which way you want to go. That biennial grass is one of the keys, really easy thing to do. And all you need to do is have, 2 seeds per square foot, 20 per square meter underneath a cereal crop, and it works really well. When we start talking about corn and silage corn back in the late 2000s, before 2010, we started playing around with putting soybeans in between the rows of the corn, using the same rate as the corn. So we would load up the planter, go out and seed the corn, turn around, load up with soybeans, put liquid inoculant on the soybeans, and then just move over 15 inches, 30-inch rows, and then seed the soys in between. If you are conventional, the easy button is using the Roundup Ready system. So this way it's just you don't have to do much thinking. You can just go out and do it. But if we're doing silage, the unprocessed soybean can give some negative growth regulators in the animals. So I add about 3 to 5 heat units beyond what we normally grow. We want to see the pod there, but we don't want to see much for beans. And so when we do that, that bean is green, vegetative, fixing nitrogen right up to the very end. You silage it off, you get a boost in your protein. You get better weed control because now you're soaking up nitrate and then still sharing that nitrate or nitrogen and protein amino acids with the corn. So you're still getting you're not getting that yield drag. And it from the trials that were done in in Saskatchewan. The soybeans at even at 27,000 seeds per acre, you're still gaining about a ton of dry matter per acre. So it's helping with the system. Another option is if we're looking conventional or organic, seeding those annual clovers prior to seeding. And, it's a real good way of getting things cranking. The weed control, once again, when we go out and we do a pre-seed tillage, when we're conventional or for organic, that is stimulating your bacteria. The bacteria are eating the organic matter and plant material and manures from the previous or over the winter, and it's breaking down the protein into urea and amino acids, and eventually into nitrate, which triggers weeds. If we don't do that pre-seed, if we have that living whether living mulch or a good mulch on the surface, once again depending on your goals, your carbon nitrogen ratio, uh, when we have that, the biology isn't overstimulated. We seed some annual clovers. They're going to do their thing, but they're not going to stimulate weeds unless you go in with a high disturbance tillage tool. And this way, when we seed our corn, if we haven't triggered the weeds and we have something growing, it's going to really reduce the amount of weeds that we do have. If we do, once again, when we get into just starting out with this, yes, we may have some wrecks. We're going to have to maybe potential do some fixing in season, but we have to remember we have to earn the right to reduce our inputs and reduce our tillage. We have to earn that right because we've been managing so long this way. Our soils are accustomed to it. We have to change how our soils think. And once again, it's crazy when you start think when you think that your soils think. That kind of clumsy, but it works. So if we go through and we're conventional, then if you look at the some of the chemicals that are used for these annual clovers overseas, they use bromoxynil and MCPA amine. You do see some damage on the leaf, but if we're not going for seed yield, it you know there's some research if you go and you do some searching on Google about herbicides on your annual clovers, you can find stuff that it's off label, which as an agronomist I shouldn't be saying, but on the flip side, they do it in the world, so it can be done. Other option, so if we are talking about herbicide applications, seed your corn, let the corn get up, do your weed control, and then go hit it with your weed control issues or options. And even if you are dealing with inter-row cultivation, uh, but as soon as you do your weed control, get out there and seed, a high legume density blend as early as you can in the season. That's fixing nitrogen. It's building mycorrhizae. It's doing all the good things for you. Then when you get to that V6 stage, about is it V5 or V8? That's a great thing with cover cropping. It's not exact. That's what I love about it. It really feeds my ADD. So go out when you're in that V6 stage, go out and seed a biennial grass into it. And, a mycorrhizal friendly broadleaf. So maybe some sunflowers. Then when you get to tassel, then you throw your brassicas in. This picture is from the Dauphin area, and he has gone out and he's seeded all this stuff together. So there's 15 different species underneath this corn crop, and with no fertilizer, he's still pulling off a 20 to 25 ton an acre silage crop. This has some forage soybeans. It has some sunflowers in there, Phacelia, annual clovers, Italian rag. It has just a whole splattering of species. And you look at the plants, you do Brix numbers on it, you look at the soil health, he's moving that needle forward. So it really, when people say that it doesn't work, I've seen it over and over and over again that it does work. And it's either the wrong species, wrong timing, or your soils just aren't, they're just still addicted to inputs. When we look at potatoes, that's a new set of issues because not a lot of zero-till planters and harvesters out there. So we need to really manage our trash when we're going to plant, when we go out and do harvesting. So this is a picture of a potato farmer that I was working with just outside of Yorkton, Saskatchewan, and Basically, he did a chicken manure application, went in full, seeded a full season cover crop, and then did a light disking to incorporate it, get that rotting process, making sure that it was a green plant. So this way the seed to N ratio is fairly tight. So it rotted down quick. And what he found was his scab and his earth tag basically disappeared. That it's amazing how we get these roots and we loosen up that soil because we have things like sorghum, which are good fibrous root system. They loosen up that soil where the potatoes are growing. All of a sudden everything starts working better. So the challenge here is, okay, so if you have a 4-year rotation, what we're going to do is spend 3 years building up our soil health, and then we'll sacrifice that 1 year potato production. Hopefully we're not destroying more soil health benefits than what we're creating. So when we start looking at and this is where that harvest period is tricky. We want to be able to have something seeded as soon as we're done harvesting our potatoes. We need to seed something, and so this is where seeding some oats, cereal rye, maybe some radishes. We have to get something in that soil to get it to make sure it doesn't want to blow or or cause more problems over that winter. Then when you can say, well, okay, that's great. This I don't know what I'm talking about. I've never grown potatoes in my life. If you look up Rocky, well, blank on his name. He's in Colorado. He's incorporating cover crops in with his potatoes. So this is the whole thing. When we start looking at these systems, there's people doing it. So, and once again, you can say, well, that's great. Colorado is different than New Brunswick. And yes, you're right. But the soil principles are the same. And so it'd be great if anybody's interested in potatoes, if you send me an email or a text, I can find out what Rocky's last name is. Just like I said, a little brain dead today. So we can help you out. So that year before potatoes, that my buddy, he had that diverse cover crop, mindful of what we don't have any disease bridges that we're going to be creating. So this way, keep your brassicas potentially away from it. We want to build that soil aggregate stability. And this is where things like Facilia and these forbs are great. They're the percent of root exit that they're doing as compared to having the a lot of carbon just staying in the upper part of the plant is much higher than most of our grasses and legumes. So having those forbs in rotation they're absolutely crucial. When we get that soil aggregate stability, all of a sudden our earth tag disappears, our root feeding nematodes disappear. We increase the nutrient availability in our system. And once again, we can do another 15-minute talk just on the root feeding nematodes and biofumigants. Biofumigants and root feeders, all that is a symptom of low aggregate stability. We build our soil aggregate stability. We get good biological activity. So this is a compost extract, putting fish, emulsified fish or hydrolyzed fish. All of a sudden, the root feeding nematodes disappear because now we have a situation where we have the predatory nematodes that are going to feed on those root feeders. So the other benefit of having these diverse blends, we have this legacy effect. And so the crops that we're growing have the benefit of the previous ribosome sheaths in the soil. And this is building a microbiome. That microbiome, a strong microbiome, is going to give us natural disease resistance. It's going to give us some shelter for some beetles that are going to be eating our weed seeds. It's going to be doing a lot of positive things. And when we look at the microquorum, and this is, two things that Christine Jones, you look her up and you look up these two topics, they come up. And this microquorum, this is increasing that plant diversity is going to give more vigorous soil microbes in our system. And that's going to trigger more microbes to cycle more nutrients. It's going to give us more available calcium. So we're not going to have that compaction. We're going to be tying up that soil nitrate, so we're not going to get the weeds. That whole system is now functioning. When you listen to Dr. James White, he's been studying rhizophagy, which was discovered in 2010, which which talks about how plants actually want to take up nutrients, and it's not from the soil solution when we add salts and fertilizer. It is actually these roots of these plants are farming these microbes, growing the microbes that it wants that accumulate certain nutrients that that plant needs, and now that plant will absorb those microbes, dissolve these cell walls, digest the cytoplasm, keep the nucleus intact, cycle it around in that plant cell and replicate it, spit it back into the soil, gives it the some stimulant and a little bit of exudate to reform its cell wall and its organelles to continue doing its microbial thing. And because it's in front of the root tip, it gets consumed again. So this way, that plant takes up molecules that include these nutrients that it needs instead of just salts that the plant has to convert over to molecules. So way more efficient of nutrient acquisition in the soil and making that plant work better. Dr. Luda Sharma, she talks about biofertilizers. And so she talks about stuff you can do on farm. They're bioavailable. And on Facebook, she has farm-made bioferts. Look her up, and she's a great resource to be able to go out and find out how we can increase some our nutrient availability in our system. The biggest thing we have to remember that nature does not work as individuals; they work as a team. So as we start looking at these ag problems, if we're going to go out and compaction, we're going to do a deep rip, it's only a temporary fix. When we go in and we're going to do a deep rip, ideally we should be putting down some humic acid. We should be putting down some emulsified fish, and we should also put in some cover crop, deep rooted cover crop. So now we're going to actually get to the cause of the problem, not just dealing with that symptom. So you always have to remember that our past management created these issues. And so use and continue on with that same management is not going to fix the problem. We need that new approach of management. We need to support our biological system. This is how our soils were built. This is how they've been functioning for centuries. And we're coming in the last couple hundred years and thinking we can short circuit the system. It's not that easy. We need to go back to our biological processes and let work with our natural system instead of try to fight it. And so cover cropping is one of those management steps to help build the soil health to regain this function in our soils. So there's my contact information. And we'll open it up for discussion. And COG does have a copy of my PDF. So if anybody wants, I think that the last picture is just a generic picture that I sent you. I can send you this updated one with a picture of me instead of just a bowl of pasta or whatever it was. So open it up for discussion.